Are we live? I think we're live right now. Where today we're having a hackathon at the makerspace of Chaihuo. So today we're building a robot arm starting from zero. We're using diffusion policy, ACT, and also imitation learning. All these tools is provided by the LeRobot framework. Let's get started and see how we build that. We have two teams for today's internal hackathon. One is hardware assembly, another is software algorithm. Hardware teams work including preparing all the components for SO100 arms. They need to do 3D printing, assemble all the components, and then do the calibration, and finally moving forward on the data collection. The algorithm team starts from the environment setting up, and then they do the calibration and data collection through the teleoperation, and then they train a efficiency and ACT model. Finally, they're moving forward on the deployment for their demo.
We are currently collecting data for the LeRobot arm. There's one camera here and another camera there for the image collection. And our goal is to put the black pen in the black box and the red pen in the red box. And the robot die.
LeRobot provides all the development tools, datasets, pre-trained models, and also environments for building up the robot arm starting from zero. So if you are a
Product designer,
software engineer,
application engineer,
test engineer,
product manager,
or you're like a non-technical background like me, you can also build a robot arm starting from the zero, made it very easy. We will host more hackathons in 2025, so join us. Ta-da! We're live. Thank you, everyone. I'm Elaine, head of AI robotics at Seed. I see there are over 100 people waiting us. It's super excited to spend this the last live stream of the Year of Dragon. In the next week, we'll enter into the new the Year of the Snake of the Chinese New Year. So we decorate our live stream room to let you feel a little vibe of our Lunar New Year. So yeah, today I'm super excited to have this topic about AI robotics. In the last month, we have this hackathon, as you watched in the beginning. The hackathon is internally at Seed. We invited our product manager, engineers to use LeRobot, or called in French LeRobot, an open source framework for building the AI robotics with end-to-end algorithms. And also they have the entire pipeline of the toolkit covering data collection, training, simulation, and also deployment. We started with this project because I think these projects also match our mission at Seed, that is making technology accessible for all. So the goal is lower the barrier of the developers, that is can use their ready-to-use tools, modules, the algorithms, and also step-by-step tutorials to build their own robots with the end-to-end pipeline tools. And this hackathon that is internally planned and organized by Yao Hui, our application engineer, and our team. So today, we sit together. We want to share about our past month's experience and also the software algorithm on the back of the LeRobot, and also the hardwares. And we prepared a demo, live demo, always nervous. And also, especially, we invite Remy, the principal research scientist, and also the author of LeRobot, joining us at the end of the live stream. We will call him and also talk about the experience of the Hugging Face project. And lastly, we also have giveaway for the LeRobot arm that is with the 2 arms, including follower and lead arms. So stay tuned to the end and enjoy the show. Yeah, so I'm gonna have a lot of tabs and be the operator and also the host today. So bear with me a little bit.
Okay, hello everyone, I'm Yao Hui, application engineer at AI robotics team. As you can see here, there are 2 standard open source robot arms named SOM 100. We have provided a video and a wiki tutorial.
Yeah, let me check the wiki. Let us check the wiki. Yes, Yao Hui wrote it all the wiki. That is the wiki including how you build this robot to start from the scratch. I mean, without the 3D printers, but without 3D printing parts. But after Lunar New Year, we will release a new kit, including the 3D printing parts, servos, and also adapter boards to help you more easily to getting started with the kit. So in this wiki, it's very detailed, step by step. So including the BOM and 3D printing guide, that is, you can get started right now. And also we including how to install the robot, setting up the environment, and also assembly, calibrate, and teleoperate with and every step we include the video we recorded, so that and then you can follow up our video to verify which if you have any mistake you want to avoid. And so as you watched in the video, so we're getting through the assembly, calibrate, and the teleoperation. So today we want to show you the teleoperation. That is a very important step in when you build the robot arm leverage LeRobot. Okay, and let's see the teleoperation. So in the next on the table, these 2 arms is already going through the calibration. Oh, so the calibrations, the goal is to, because we have 2 arms. One arm is follower and another is a leader. So we need to calibrate all the servos, means the joint of the arm, that then they can follow up. They can synchronize each other, and then after the calibration, we do the teleoperation for the data collection. So we'll jump the step for the teleoperation, but you can check out our videos. Yeah, so let's show the teleoperation.
Okay. There are some panda models here.
Cute.
So I will move it into the box. So, okay. And I get another one. Okay. I made it.
So so this is for data collection, right, Yao?
Yes.
So during our experience, I remember we have repeat your current specific task is pick up panda.
Yeah.
And so during our experience, we need to repeat that process for 50 times, right?
Yes.
And each loop you need to close in 90 seconds.
Yeah.
Yeah. So notably, this is a very long and very careful and kind of tedious progress. So you need to be very careful when you start the first task. Well, we will recommend you start from the very simple task and pick and place, and then you can get familiar with your arm or with the arm, and then after that, and then you can be more skilled with the arm and to execute more complex tasks. Yeah. So Actually, I remember Aloha from the Stanford research. They also use a similar teleoperation. So this is the Aloha. So this is the Aloha project by Stanford University. It can so Aloha it is famous for the four arms of the robot. It can learn from the humans to cook as in this video, and also it can do the clean and also do the laundry tasks. So you can see in this paper, and then they do the teleoperation. They have the teleoperation part here. They have four arms, and the developers is manually on the back and to do the operation, and then the follower two arms, they just follow the leader. Yeah. So today we will demonstrate LeRobot that is very similar using the same algorithm called diffusion policy and SAT. So it's combined the two low-cost servos, and servos can build as a robot arm and can execute the similar task as Aloha. So this is a very cost-effective solution, and not only you can build the arms, but you can learn all the algorithms and philosophies back of the projects. Yeah. So Yaohui, I have a question. So through our in our videos, in our hackathon videos, from the assembly to the deployment, I want to know which part you think is the most challenging for you because you have go through this process pipeline many times. You memorize in your mind. Yeah. So, but I still want to know what is the biggest challenge right now.
Okay. During the process of data collection, we found that setting up the environment in the real world needs a lot of work and great caution. For example, I changed the interlighting, background, or position of the camera, all affect the development results, even lead to bad results. So I try to integrate the robot with SXing and the ROS2. I import the SOM100 into SXing and create an simulation environment. Then I use the ROS2 to establish communication between real arm with SXing. Then I can control the leader robot arm in the real world, and the follower in SXing will follow immediately.
I see. So do you mean like for during the entire progress, the data collection is the biggest challenge right now?
Yes.
Because that is also very similar to CNN model. The computer vision model. When you do the data collection, if the light is different or the object is not very similar, it will affect the final accuracy of the model, right?
Yes.
So very similar to the robot data. So ISAC-SIM is provided by NVIDIA. It's an NVIDIA platform. So that is solve the problem for data collection, and it provides a simulation environment, right? Yeah. So we're gonna check that later.
Yes.
But for ROS, is that your integrated ROS, is that the ROS is mainly for control?
Sure.
Okay, cool. Yeah, so let's check out that, let's check the wiki again for how to use ISAC-SIM to control the SO100 arm. I think this will be a real to sim. We're gonna present a live demo to show how we. So we're gonna teleoperate the one leader arm, and it's gonna be simulated to the ISAC-SIM. And we're also gonna check in the ISAC-SIM how it can simulate not only the objects but entire environment, including the sensors, and also we have prebuilt some objects. And what is more interesting thing, it can also simulate the force, and you can feel it. It's just a copy and paste the real environment. Okay, cool. So this is the wiki. The result, as you can see, this is the result. So we recorded previously. So the robot arm here, 1 second. The robot arm here can move in a regular pattern. Yes, and that is we imported firstly. But I want to mention a little. I want to mention here this one. So what I want to specifically mention is the called graph action. So here for the this is called action graph that is provided by ASEC platform, which means so it is provided a visualized workflow, a code workflow, and also provided the modules you can just drag and drop to design your workflow, and also it can map the workflow to the and just map how the robots move in the environment. So it is very developer friendly and more easily to get started. So let's go to Yahui's laptop and see the demo. Okay.
Okay,
So
share
we're
my
gonna
screen.
simulate, or we're gonna see the arm, how the arm real simulated, right? It's okay. It's wait 1 second. We're facing some technical issue. Always. It's that good right now? No. We're facing some technical issue. 1 second. Okay, we got. So
Okay.
here is we're in the Yahui's laptop right now. Okay.
Okay. So I won't go through the step by step here. Let's open the ASEC scene, and you can see an empty world. Then open the previous file. Okay. You can see a robot arm under 3 models.
Cute boy. Flying.
Yes. I have added 3 cameras here.
Where is the camera?
Let me check.
Because it's
One of them
not
is
very
here,
obvious.
Here.
Okay, on the
At end
top?
of yes.
On the robot arm, actually.
Yes.
Yeah.
Another one is here
On the top. Yeah.
Last one is here.
Oh, and the next.
And we check the frame.
Okay, we're gonna check the camera view.
Yes. Okay.
Let me see that. Okay, it's the top. And this is the camera on the robot arm. Can you go back to the top?
Oh, yeah.
Okay. Now the next one. Oh, okay. Let's
Okay.
see. Yeah.
So
So in the real workshop, we also can put as many as cameras we want,
Sure.
right? Cool.
So, give me some.
So we're gonna pick up something. Pick up one of these 3 toys.
Let's open my modified teleoperation code.
Okay. So in the LeRobot, their original projects, they didn't add the ISACs in the interface. You wrote the additional Python interface, right?
So yes,
Okay,
so I
I
made
see.
some modifications to
I
the
see.
original LeRobot codes. Okay, and then you can see
It's
the
clear.
frame is
So
updating in real time.
where operates the black one is that the leader arm, and in the simulated environment, it also moves together. Cool. Yeah.
Let's grab something.
You're not scared.
I'm not scared.
I think that one is hard.
It's very
it's
difficult.
sleeper. Okay, let's try
Actually-
the middle one.
Okay. Oh my god.
Okay, it's almost. Oh!
Let's try again.
This reminds me my experience to grab toys. Okay, we can try that. Jenny.
Okay. Oh my. I need to change size.
Can you turn off your mic? Okay. Someone is asking us.
Okay.
Okay.
So I need to change some.
1 second, as we're saying, like in the comments, that to turn off our mic. Technical issue.
It's too big, so
It's off already.
okay.
One.
Yes.
Okay. Okay, it's too big, but I want to try this. Yeah.
Okay. It's cool.
Okay. But you drop that. I want to see the weight.
Let's just drop.
Okay. Cool. So when you're pushing that or when you grab that, you can feel the force, right?
Yes.
That is the so. Yeah, so it means it simulates everything and also the real operation in the Isaac sim. So, but that one is powered by the physical engine in the Isaac sim, right?
But so far, it's this project is just
Raw.
rough and experiment. But I will make
That one
it
is
available to
powered
everyone
by the
in the
physical
future.
engine in the Isaac sim.
Yeah,
right?
I
So
need to
we also
close the
look
live
forward
stream.
to
Hi,
everyone
Harry.
that can join our
Hello.
Can you hear
to
me?
turn the PR. We are
Actually,
calling
they are
NVIDIA
talking
people
like the part 2
and
for the live
LeRobot
stream,
people
so I think
and also
maybe
all the
you
community
can get
and to join us.
get a
And so we're
connection
gonna
with
release
this
this
Zoom
this
within
GitHub
20
repo and
minutes,
wiki
or
page on our
it starts
website,
like
right? And then
from
everyone can see that.
3:30
Oh,
or
but
30,
also
3:40 or
please
45.
join our
I think
Discord.
it's going to be
Join
worth.
our Discord group.
Could you
and
just
then
wait for the
you
Zoom and
can
then
come to
when
discuss
Elaine
with us.
close
So
the
you can scan
close
the QR code
open
to
the
join
camera on
our
Zoom, then you
Seed
can
Discord
just
group.
have the conversation. Is that okay?
Yeah, perfect. I will wait over here. Do you know how long will be the conversation?
So
The conversation may be like
entire process
around 10
through
minutes.
our hackathon videos
Is that
and
too long
also
or?
with
No, no,
teleoperation.
no,
I mean,
perfect,
the result
perfect.
part
Okay,
I will wait here.
seems very easy.
Yeah,
but
I also like
on the back,
I also
that
let you
is
know
built
before like
by
5
the
or
LeRobot
3
team
minutes.
and Isaac
Is that
sim
okay?
team by NVIDIA
Perfect.
and putting a lot of efforts
Yeah,
to make
thank
it
you.
easier
Thank you
for
for waiting.
everyone. And to including this ready-to-use modules and also writing the interfaces like Yahui write in the interfaces in Python, and then to help all the developers complete the projects. So it's very good. So I want to mention more about the Isaac sim. Isaac sim it plays a very important role in the entire process of the AI building the AI robots. That is also mentioned by Jensen Huang in his keynote in the CES. So NVIDIA is presenting the idea of the 3 computers. So one computer is for train and also fine-tune the very powerful foundation generative AI models. And also they have another development platform and leverage Omniverse and also the Isaac sim for the data collection, simulation, and also testing. And also, finally, you need to onboard. You need to validate. You need to validate the policy and deploy the policy on the real-world robots. Can be powered by NVIDIA Jetson or Thor. They're gonna release in 2020 in this year. So for a real-time inference. So for the deployment for the deploy on the Jetson O-ring. So today we're deployed on our ray computer. So this is a very tiny box that is powered by the Orin Nano and also Orin NX. You can see that it's very tiny, smaller than my hands. So and also it is a modular design. So let me share the ray computer. This one, the ray computer. So ray computer is that is very tiny and modular design. So why it is designed for robotics? So first, the feature is very wide voltage range. So it can support up to 54 DC input compared to our ray computer. Ray computer only support 19 volts. That is kind of not very fit for the robot deployment. And also, what is more special is we get all interfaces in two sides because we understand in the real robots deployment, usually the space is very constrained. So we keep that into two sides, and then you can leave more space for other sensors interfaces. I mean, save the space for the internal robots. And also we get a lot of USBs and also I2C UART to let you to connect with many sensors and then when you develop robots. And also we provided the customization. So for example, if you want to replace USBs to the GMSL, and then we can provide the customization. So this one, Ray Computer Mini will be both good for development and also the deployment because the module is using the production grade module. And this one is also supports upgrade to Orin Nano Super Mode. So you can unleash more AI performance using the Orin Nano. So yeah, Yaohui, I know you're very experienced with building robots. So before you joining Seed, you already built from zero for AMRs. You have robot arms, you have drones. So I want to know, compare those robots with these two arms. What are the difference?
For my way, in the first step is define the robot task. For example, cargo handling for robots, drone delivery, or sorting with the robotics arm. The second step is choose a suitable sensor, such as LiDAR, GPS, camera, and so on. Then I will select a suitable environment perception algorithm, maybe G-mapping, cartographer, Orbi SLAM, or YOLO mobile net. And after getting the target point, I will design a cost function or planning control algorithm to tell the robot how to get to the target and avoid the obstacle. So this can be called a simple model base.
I see. So you mentioned there are a lot of models.
Yes.
You mean there is YOLO, mobile net, and G-mapping. So do you mean so every task is designed
Sure.
manually and
Yes.
planned? So it means that is based on the manual experience. So if you change the task, there is a risk that you need to start over the design, right?
Yeah, absolutely.
I see. Yeah. So a model-based approach means that in a robotics task, there are multiple fundamental models. So as Yaohui explained, so like the robots, they are using the end-to-end models. Like we presented through the data collection, we simply specify the task, and the middle process is like a black box. So in the paper they also show they push a letter T. So through the different route and then ultimately it can push in the right position of the ladder. So the same way we pick up the panda. So no matter how we pick up, so ultimately when we predict the actions, when we deploy that, it's gonna pick up. So that is truly it truly maps the inputs directly to the outputs. So I collect the data of the pick up the panda, and the outputs is pick up the panda, no matter how I'm gonna do that. So it's gonna skip the modeling and the planning steps. So before you need to planning a lot of different steps to achieve one task, but right now I only need to achieve one task with one single model. So actually, this also reminds me our last live stream with K-Scale. K-Scale, they are building humanoid robots,
Right.
and they also provided the single neural network. So they have fed all the sensor data, including microphone and also LiDAR and a lot of cameras, and also the joint of the servos, and then into their single neural network called efficient VLM, and this is for outputting the robot actions. So I don't know if they're using the diffusion policy, but it's basically in the AI robotics right now, especially in body AI.
Right.
It's the similar of philosophy. The similar ways for the end-to-end model, right?
Maybe reinforced learning.
Oh yeah. Yes, exactly. Yeah, so the original Aloha system using the go back to the Aloha. They use the architecture called ACT, that is called action trunking with transformers, which is takes the images from the multiple viewpoints and the joint positions as input and predicts the sequence of the functions. So in the above, that is the ACT model, and also in the below, that is the diffusion policy. So in the LeRobot project, both algorithms have been adapted in the project. So the difference between these two algorithms lies in their approach to the action prediction. So the ACT algorithm predicts action sequencing using the transformer. So through the transformer encoder and decoder, they will output the joint of the prediction for actions, right? But they're lying the same goal. But however, if you see in the diffusion policy in the middle, it is going through a process called Gaussian noise and denoise process. This is a process to enhance the generalization, and in the end, you can also for your output the prediction of the actions. You can choose either CNN or the transformer. So that's the main difference. So ACT is purely a transformer, but diffusion policy adding a Gaussian denoise progress. Yeah, so we covered a lot from the see the arm and also how we do the teleoperation, and quickly go over the model. We learned a lot from their paper and also the entire LeRobot projects. I hope actually we tried the best to explain that. I hope we covered. I don't think we covered very enough. I highly recommend to go check out the LeRobot paper and also their diffusion policy paper and also LeRobot projects. So today I'm super excited. We invite Remy, the author of LeRobot. So we're gonna live connect him, and also let's see how does he think about the current embodied AI. So let's go to the Zoom. Zoom. Hello, Remy, can you hear me?
Yes.
Okay, so I'm gonna push this video. 1 second. Okay, here we go. Hi, Remy.
Hi.
Very nice have you join our live stream. Yeah, it's a great pleasure. Invite you.
Yeah, it's also my pleasure.
Yeah. So Remy, yeah, thank you so much for joining us. I want to ask you through your research and also your LeRobot project at the Hugging Face. So what do you think the most challenging parts for the current embodied AI?
Yeah, I mean, the approach we took with LeRobot is to try to simplify as much as possible all the steps to make them accessible to everyone. That's why I think it's nice to have a small robot, a affordable robot that you can assemble and calibrate yourself, collect the data, and train everything. So right now, the most challenging part is to make it generalize
Yeah.
to new environments. It requires a lot of data. Right now, we don't have we don't have foundational model right now available on the robot, but we are working on it. So we are trying to address this. And there is also the reinforcement learning
Right.
aspect where the robot can interact with the environment
Yes.
and generalize. That's also something we are working on. So in the next couple of weeks, I think I mean there will be some like game-changing aspect coming to the robots.
Oh, really? We're super excited for that. Yeah, so as you mentioned, make the robot more accessible. That is why we launch this kit, the hardware kit, that everyone can buy them together within one package. And after Lunar New Year, we're also adding the 3D printing parts, and then everyone can study it more easily. And yeah, so you mentioned the data collection. So in our live stream, we also presented so solving the problem, part of the problem of the data collection. I mean, accelerating this progress, we can use the Isaac sim. So what do you think the current way, including the Isaac sim? So how can we accelerate the data collection steps?
Yeah, I mean, of course, simulation can be very helpful. Isaac Sim is a really great simulator. You also have Mujoko,
Yes.
so we try to be compatible and we'll add more simulation. Maybe, I mean, you already have Isaac Sim, which is really great, especially for for learning to walk. That's also something we would like to add to the robot. Simulation can be important. The approach we take with the robot is also to focus on the real world. So we still think that even though sim can accelerate things, can help you debug, can help you get some intuition on how algorithms work, I think it's a nice it's complementary to iterating in the real world as well.
I see.
Because, for us, I mean, we learn in the real world, but we can also train ourselves in simulation, like playing video games. So I see it like this.
I see. So besides the simulation, you mean in the model wise, you like the robot can really think. I mean, first they understand and then think about for the next the predicting actions, right?
Yeah, I mean, if you have a setup in simulation with Isaac Sim, which is a really great simulation, yeah, you should use it and train in simulation and try to see how it generalizes in the real world and so on.
see.
Definitely.
Yeah, I also have a question that is we searched online and is saying that is about trajectory-based learning for the generalization. So for some end-to-end algorithms, they require the joint data as the both input and output, while others they only use the end effector trajectories as the input and output. So I want to know how you compare them. What is the advantage and disadvantage for these two ways?
Yeah, so end effector position space, it's like the location where your gripper is in the space, and you can predict it relative to the base of your robot. So of course, then you can generalize. If you learn on one robot, you can generalize to another robot because you just need to predict the position of the end effector, maybe a similar end effector, but the arm can be very different. And then there is an extra algorithm that generate the motion. So you predict the location, the state, and the external algorithm generate the motion. So I mean, the advantage, you can change the robot, and if the algorithm is well implemented, it can generalize. But if you predict in the motor space, in the action space directly, first it's supposed to be simpler because you don't have this extra algorithm, which can be quite complex. And then I mean, I believe that on the long term, predicting the action directly could be better and could also generalize as well. So this is my belief, but it's like,
Depends on the model.
yeah, I mean, right now it's just the beginning of it. We are working on very simple models on simple data sets, but at some point it will be like a language. We'll have a ton of data from different robots, different language, and with vision, language, action model, so the foundational model, we could translate from a robot to another, like
Oh yeah.
from from English to French to Chinese. I mean, like a language. And I really want to develop these data sets, these big data sets, so that we can train this kind of model that could be robot agnostic, but still predict in the action space. But in the first time, I think the joint space is really important. And if you record data in the joint space, you can also access the action space. I mean the end effector space. Sorry. You can also access the motor, the action space.
I see.
And last thing, I would say that your initiative is amazing because the goal is also that a lot of people know about this technology, gather data together, crowdsource big data sets in various environments, and that's how we can go one step further in this field and have real robots like in the movies. That could be great. Yeah.
Yes, you are correct. So I look forward to that. So for building a very big data set, and that is very important to have everyone can join this open source project, right?
Yeah. I mean, that's the power of open source. And I think robotics had struggled with this. You had data silos, and now it's the first time that we have this kind of technology. We already have it for large language model with internet, vision language model, and now maybe for robotics that could be that could be amazing.
Yeah, and also it's very luckily now I mean, Aloha robots is already low cost, but that is not low cost for everyone. But LeRobot, I mean, the SO ARM 100, that is more affordable for developers and also for hobbyists. Like I don't have any coding background, but I really follow our hackathon and building the robot arm. Yeah, so yeah, it's more cost effective and a lower barrier. And also we actually were having our hackathons in right after Chinese New Year in Shanghai and Shenzhen, and then we will go to the GTC week in the San Jose. So why we build the hackathon is so we also want to let let people to join us to real hands-on these robots to build the confidence, and then everyone can leverage the robots and then creating the big data sets.
Yeah, amazing.
Cool. So yeah, thank you so much. It's great having you, and so I look forward to your a couple weeks later. Is the biggest, very big updates for the LeRobot, and maybe we can have more. Oh, I'm sure we will have more tutorials and also videos and adding into our next hackathons.
Yeah, thank you so much. I wish you the best hackathon possible. Learn a lot. And yeah, I mean, together, I think we have the possibility to advance the field forward. So
Yeah.
looking forward to it.
Okay. Bye.
See you. Bye bye.
Bye. Okay, great. That is a great call with Remy, and yeah, I mentioned we're gonna have the hackathons. The hackathons is our first one. It will be in Shanghai and then in Shenzhen, and we will invite around 30 engineers and follow our experience. And we host it internally, and we also have the meetup event after we in the demo day of the hackathons. So here is our hackathons information. 1 second, let me go to the page. So this is our hackathons, the event page in the San Jose in the GTC week. So during the hackathon, we're also gonna invite Hugging Face team and also NVIDIA team as the mentor and the speaker for the hackathon. So we will host that in March 22nd to 23rd. That will be 2-day hackathon just after the weekend of the GTC week. So make sure you can join if you are locally in the Bay Area. And we also provide some prize, including the ARMS and Orange Nano Super Kit, and also a lot of prize. Yeah. Okay, great. So in a summary, I think we covered a lot. So LeRobot is a state-of-the-art machine learning for real-world robots. It including the approaches, data sets, models, and also tools for the robotics in PyTorch. So from our past introduced projects like Jetson Container, that is created by Dustin, the principal engineer at NVIDIA. It's also follow the similar philosophy, but because that is also provided ready-to-use modules and created the interfaces, lower the barrier for the developers. So the robot is focused on the robotics. Yeah. So, and the 2 key things in the LeRobot is one is the algorithm. It's leverage ACT and also diffusion policy. And for the hardware, it provides the BOM list for SO ARM 100 that you can directly get on our online store right now. And also, it also compatible with other different robot arm, including Aloha and Coach V1.1. Yeah, you can check, go to their GitHub page and check their robot arm. So that's it. That is our live stream today, but this is not the end. We are going to have the giveaway. So it's giveaway time.
But we get some question.
Can we get the giveaway first, and then we can, yeah.
Okay.
Cool. So the giveaway, Jenny. So the giveaway we're gonna screenshot for the first or the third. Okay, the first one, you're gonna type LeRobot, LOIOBOT. So when I'm gonna see start and then stop, and we're gonna screenshot the first one in the Jenny's cell phone. So are you ready for getting the giveaway? Getting the giveaway for the LeRobot arm. This one. So we're giving away this arm set, this 2 arms set for the standard arm 100. Okay. So it started already. So I'm gonna say stop in 3 seconds. Okay. Keep. Okay. 3 seconds. 3, 2, 1. Stop. Okay, we got. So who is the first one? Wait 1 second. So the first, I cannot see. Can you press? 你需要点一下你的屏幕。No, I cannot see that. Can you just let me know the name? The lucky one. Who is the lucky one? Okay, who? Jeff? Last name? Okay.
Where is Jeff?
Leisinger. Congratulations, Jeff Leisinger. So we will contact you. We will leave the comment. I'm not sure if I pronounce your name very correct. So we will leave the comment in the video, and also and then you can email us at edgeai.seed.cc, and then we will mail you this gift after Chinese New Year. Okay, cool. So let's get to the questions. Okay, let's see. So the first one is
can you drive the robot with a joystick from the remote location?
So the first question by Christopher, can you drive the robot with a joystick from remote location? Yes, the answer is yes, we can synchronize the posture of 2 robot arms via the wireless transmission. So the joystick, yes, you can do that. That is also a way for the teleoperation.
Yeah.
By Brandon Lee, why use a camera that is limited to our wavelength? Can you use something that would see the environment differently than we do? Yes. We're talking to some depth camera partners like Sensing, and also we are working with LeRobot, Orbitag. Yeah. So we are doing the compatibility right now. So the next step will be try the depth cameras on our computer Jetson. Yeah. The next one, we're gonna have 2 more, right? Okay, we're gonna have 2 more. So by Andy Key, can we use Genesis simulator? Oh, that's very cool. That is the work we're doing right now.
Guess my next move.
Yeah. So simulation in Genesis is our next step, exactly. So we will providing the step-by-step tutorials. So stay tuned to our newsletter and also wiki updates. We also going to have the videos. Yeah, it's the right guess. Oh, and another one is: do you have to 3D printing your own arms? Yes. So yes, as I mentioned, the current products, the package that is only includes our servo, including the servos and also adapter boards. Actually, we built a new servo adaptation boards using it can attach with shell for the controller, and it can attach with shell. Frank. Can you make that zoom to see? So this is just our new expansion boards that is we developed. So in the next batch, we're gonna add this to the package. Can you zoom and then we can see that? It's pretty small. Right, thank you, Frank. So this is the servo adapter boards we just developed and then can prevent downtime, right? For the when you run ARMs, and so it make your workflow more stable. And also you can attach with shell as a controller boards. So actually we've seen in a paper called Armor, it's the Armor is using multiple shell in the humanoid robots and plus the 12 mini LiDAR to also sense the environment. So so this is our new product. So stay tuned for this. Okay. Okay, I think that is all of our live stream today. Thank you, everyone. So I really hope everyone who's gonna spend the Lunar New Year holiday will have a great time with your family and the friends. So we're gonna see you in next 2 weeks. And let's keep studying new robots and play with new robots. And maybe see you in the hackathon in any city of China and US, maybe Europe. Okay.
Happy
Thank
New
you.
Year. Bye,
Happy
guys.
New Year. Bye-bye.